Geometry Lesson 4.8, dealing with isosceles and equilateral triangles. Recall that an isosceles triangle has at least two congruent sides. The congruent sides are called the legs. The vertex angle is the angle formed by the legs, so the angle by itself up there, angle 3, would be the vertex angle. And then the base angles are the two angles that are the same in the isosceles triangle, 1 and 2 there. Okay? So the isosceles triangle theorem states if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So if the legs are the same, the angles opposite B and C in this case would be the same. And then the converse is also true. If two angles are the same, then the sides opposite them are the same. The isosceles triangle theorem is sometimes stated as base angles of an isosceles triangle are congruent. The length of yx is 20. Explain why the length of yz is the same. Well, if this is 40 and this is 140, this would have to be 40, which makes it an isosceles triangle, which means that that would have to be 20. Find the measure of angle F. Well, this is an isosceles triangle, so we would take 180 minus 22, and then we would divide that by 2, since those would have to be the same, which means both D and E would be 79 for an isosceles triangle. Find the measure of angle G. Well, this triangle is isosceles because the legs are marked as such, so we can set the expressions equal. X plus 44 equals 3x. Subtract x, divide by 2, so x is 22. Plug it in, you get 66 degrees. Okay. All right. Equilateral triangle, corollary. If a triangle is equilateral, then it is equiangular. So an equilateral triangle, if a triangle is equilateral, then it's equiangular, and vice versa. So all the angles add up to 180, so they would each be 60. And if it's equiangular, then it's also equiangular, equilateral. Okay. Find the value of x. Well, it's equilateral, so you know that's also equiangular. So we can set 2x plus 32 equal to 60. So 2x equals 28. So x equals 14. Okay. Find the value of JL. Well, if it's equiangular, it's also equilateral. So we can set 4t minus 8 equal to 2t plus 1. So add 8 to get 9, subtract 2t from 4t. So that gives you 2t equals 9, so t equals 4.5. Plug that back in, they're all the same, so it doesn't matter which one you get. 4.5 times 2 is 9, plus 1 is 10. So all the sides would be 10. Okay? All right, a coordinate proof may be easier if you use the x-axis and the y-axis to kind of help you out, as we know from before. All right, prove x, y, z is isosceles. X and y are the midpoints. So to prove it's isosceles, we would want to show that these two side lengths are the same. All right, to do that, we need to find our midpoints here. Well, 2a plus 0 is 2a divided by 2 is a. 0 plus 2b divided by 2 is b. Negative 2a plus 0 divided by 2 is negative a. And 0 plus 2b is 2b divided by 2 is that. So we know that that's 0, 0 there. So now we're going to use distance to show that xz is the same as yz. All right, distance formula. Well, let's do xz first. Well, how far is it from 0 to negative a? Well, that's a, so a squared, plus how far is it from 0 to b? Well, that is b, and then you square it, and then you take the square root. That's all we can do there. With the coordinate proof, we just leave it in terms of a and b. There's nothing else we can do with that. All right, let's move over to yz. Well, how far is it from 0 to a? It is a, and we square it, And then our change in y, how far is it from 0 to b? It is b, and then we square it. So a squared, square root of a squared plus b squared, square root of a squared plus b squared. Those are the same, which means that that is an isosceles triangle using a coordinate proof. Okay? All right. That is a wrap on 4-8.